between two ground points, I have to get a beep in the multimeter and a low reading. And the most important here is that the reading between these two ground should be the same between these two here, and the same between this one and this one, same between all grounds in the board. If you find a section not beeping, it might have a broken trace or lifted path. And of course, when we check between grounds like this, we confirm that there is no crack in the motherboard. You won't believe how many motherboard problems are caused by something as simple as bad grounding, from no power to random restarts. The ground is the silent foundation of your entire board. Today I'll show you how to find, test and understand ground like a pro, and you will never look at your board the same way again. And by the way, if you want exclusive content and free schematics, join me on my Patreon page, link in the description. And hit subscribe, turn on notifications, and don't miss this series. So let's begin with the first section where we gonna see what is the ground and why it's so important. So in the motherboard, as you can see, we have ground everywhere. Also these thick traces and lines are ground. Here also we have ground. So the ground is the reference voltage 0 volt for the whole motherboard. Every IC, capacitor, resistor and MOSFETs needs the ground as a return path for current. Without a proper ground connection, unstable readings, no boot or power short. Ground points are usually large copper areas, screw holes, and connectors and parts shells, HDMI, USB, audio port, etc. The ground line is often the thickest copper plane inside the board, ensuring stability and noise reduction. Section 2, we gonna see how to identify ground points. Very easy, by using the multimeter and by selecting the continuity mode and by placing the black probe in every point for ground here or in the screw holes, any ground points. After that, we use the red probe to look for grounds on ICs and connectors anywhere. For example, for the battery connector, let me check this pins. If it beeps, means we have grounds. As you can see, ground, ground, ground. And if you pay attention very closely, we have these 3 pins that beeps are connected to a wide area. Do you see? Connected to this thick area, that means the ground that is connected also to this thick area. But for those are connected to the ceramic capacitors, means here we have voltage, because always the input voltage is connected to ceramic capacitors for filtering purposes. Please, before diving into the course, we'd like to give a huge thank you to the sponsor for this video, PCBWay. PCBWay offers many services ranging from PCB production and assembly to 3D printing and a variety of materials. CNC machining, sheet metals fabrication, injection molding, and more. PCBWay makes it easy to get custom parts for your project. And if you don't like to work a lot with a soldering iron, they can even assemble your PCBs for you. That's the PCBWay. Now back to the video. The same for ICs, the black probe on the ground, and for IC, if I want to locate the ground, I can just pass the red probe here above the pin ICs. The pin that beeps means connected to the ground. Let's check the side. As you can see, means this pin here, the second pin, connected to the ground. What about connector? The same thing. If I check pin one by one, this one, the pin here is the ground, this one is for voltage, The pin here connected to the ground in this connector. What about this one? The same working principle by passing the red probe. As you can see also, we get the ground. So remember, always we place the black probe on any metal part or screw pad, touch other points with the red probe. If it beeps, that point is connected to the ground. If it doesn't, means not ground. Common ground points are screw holes, metal shields or heatsink, negative side of capacitor. So for capacitors, the negative side is always connected to the ground, and of course this is the negative side where we have color. And of course in some motherboards we find even plus, as you can see, for this side and minus here. Do you see plus here? So this side over here is always connected to the ground. So let me put the black probe in the ground everywhere. Here for example, here this is for ground. So if I touch this side, as you can see, we get a beep. But about this side, no. This is positive terminal. Here, positive terminal, we have plus. But this side, I will get a beep, as you can see. So remember, the negative side of the capacitor is always connected to the ground. Here is a pro tip. Always confirm ground before testing voltage. Wrong reference can mislead you. That's why ground is the most important while testing. Okay, let's move on to section 3, where I'm going to teach you how to test ground properly. So always we use the continuity mode, and of course I'm going to teach you how to check the ground connectivity across the entire board. Please attention, this kind of testing I'm sure you will hear it for the first time. Look, between two ground points I have to get a beep in the multimeter and a low reading. And the most important here is that the reading between these two ground should be the same between these two here, and the same between this one and this one, and also same between this, same between all grounds in the board. So between different screw holes, between the negative terminal of the DC jack and any ground point, if you find a section not beeping, it might have a broken trace or lifted path, or a ground plane separation due to a damage. And of course, when we check between grounds like this, we confirm that there is no crack in the motherboard. For example, let's assume that here I have a crack over here, like this, but you cannot see it. If I have a crack like this in the motherboard, how can I know? Is by testing the ground between all grounds. So between this one and this one, it will be good, no problem, because we don't have crack. But if you test between this one and this one, like this, you will not get a beep, or you can get here a high reading. This is problem, means you have a crack in the board. Always you have to get a low reading and the same reading between all grounds. And now let's move on to section 4, where I'm going to teach you common ground related problems. So when your laptop won't power on, means missing or broken ground near the DC jack. Short circuit, power rail connected to the ground. Strange voltage drops, weak ground path, or cold solder joint. Touch issues or noise, poor grounding in signal circuits. Remember this tip. A motherboard without good ground is like a city without roads. Nothing moves correctly. So section 5, I'm going to give you some tips, tricks and pro insights. First, always clean and inspect mounting holes. Oxidation can block ground contact. Second, when testing power rails, always reference your black probe to a known ground point. Third, if a short is suspected, compare ground resistance with a working board. Fourth, never assume two grounds are connected. Always test continuity. Fifth, mark all verified ground points with a marker to speed up future work. So now you know ground isn't just that black wire, it's the foundation of your motherboard entire life. Next time your board acts dead, check ground first. It might save your hours of repair time. And if you want exclusive content and free schematics, join me on Patreon, link below, and hit subscribe, turn on notifications, and don't miss this motherboard testing series. Thank you very much, and you are very welcome.